So we're looking at some limits here, a couple more examples. This is a one-sided limit, and notice that if we plug in 1 and do our direct substitution, we have the limit as x is approaching 1 on the right of 1 over x to the 2/3 power. That's one fraction. And then outside of that fraction is plus another fraction, 1 over the quantity x minus 1 to the 2/3. So if we go in here and we plug in 1 for x, we're okay for that first piece, right? We would have 1 over 1 to the 2/3. Well, 1 raised to any power is 1. The problem is when we plug it into this piece right here. And so we really want to know if this is shooting off to positive or negative infinity. So if we plug in 1 into the first piece, the first fraction, we saw that we got back 1. If we plug it into the second piece, that's where we get a problem because 1 minus 1 is 0. We can't have 0 in the denominator. And so we have to think about which side we're coming in on and to think to ourselves, is this going to become back a positive or a negative number? And so we're plugging in values of x that are going to be greater than 1 because we're coming in on the right-hand side. And so think of it, if I'm plugging in a number greater than 1 and subtracting 1, that's a positive number. So this is going to be a positive number. And raising a positive number to any power is always positive. And so I know that I'm going to have 1 all over. Well, this is a vertical asymptote here. And so I just need to know, is this going to be shooting off to positive or negative infinity? And so this would be plus a very large number. So this is really plus infinity or something that's growing. And so 1 plus infinity, this gives me that this is equal to positive infinity. So same sort of idea, I can think about it coming in on the left-hand side. So the limit as x is approaching 1 on the left of 1 over x to the 2/3 plus 1 all over x minus 1 to the 2/3. Again, if I do direct substitution, I'm okay with the first term. And when I plug in 1 for x, I'm getting back 1 plus, again, I can't just plug in 1 for x into the second fraction because that's giving me 0 in the denominator. And so again, I want to see if this is going to be a positive or a negative number. And so since I'm coming in from x 1 on the left-hand side, I'm choosing values close to 1, but less than 1. And so a number less than 1 minus 1, this right here, this is going to give me, when I plug it in, a negative number. And so as I get smaller and smaller and smaller, it's 1 over a very, very small number, but it's a negative number. And that's 1 over a very infinitesimally small number close to 0 is going to go to infinity. In this case, this is going to be plus minus infinity. So negative infinity plus 1, this is going to be negative infinity. So this tells me that this is shooting downwards at that asymptote. Same sort of idea when we go in and we look at it as the other problem spot. I can see that I'm going to have a vertical asymptote, whatever sets my denominator equals 0, but not also my numerator. And so if I look at my first fraction, I'm going to have a problem with x equaling 0. And so we can look at the limit as x is approaching 0 on the left and the right and see what's happening at that asymptote, vertical asymptote. Is it going to be shooting off to positive or negative infinity? And so limit x approaching 0. I tend to like to move left to right. So let's just go from the left. This is 1 over x to the 2/3 plus 1 over x minus 1 to the 2/3 power. Okay, so knowing your information about exponents and how to rewrite these as radicals is kind of helpful. If I have some, let's say, b raised to the m divided by n power, I can rewrite this in radical form. So the denominator of my rational exponent, that is going to be the index, what root you're taking. And the numerator, this m as in Marcia, mom, is the exponent, or what power we're raising our base b to. Normally, though, if you're taking a root of something, it's easier to take the root of something that is smaller. And another way, equivalently, that we could write this is that this is the nth root of b raised to the m power. So I can pull that exponent of m outside of the parentheses. Okay, I can go totally more into that, but that's not the whole focus of this problem. So notice that our numerator here is the square. And so I notice that whatever number I plug in there, I'm going to be squaring it, and I'm going to be taking a cube root. So if I had b to the 2/3 power, another way to think this is I'm going to have the cubed root of b squared, or I can think of it as the cubed root of b to the 2nd power. Squaring anything is always positive. And I have that in both of my denominators. So I can kind of do some reasoning here. Even though x is approaching 0 on the left, that actually means that x is less than 0. It's a negative number, but 1 over something that I'm squaring is going to be positive. So this is going to be going to positive infinity for the first fraction. Plus, I just need to make sure that this is not an infinity minus an infinity, because that's an indeterminate form. But if I plug in a number less than 0, I have a number less than 0, close to 0, minus 1, that's still a number less than 0, which is negative. But I'm again squaring it. So I can reason to myself, well, that negative squared is going to be positive. So this piece is also going to positive infinity. And so as we're coming to x equals 0, that vertical asymptote, the y-axis, the graph is going to be shooting upwards. Same reasoning that we just talked about. I know then it doesn't matter if I'm coming on the right-hand side, I'm going to get the same result. Let me see if there's any questions before we look at the next example. So I want to go through and actually fix a couple things. So the first thing is going back to that reasoning, and I'm saying that we are going to square the number that we're plugging in, and then we're taking the cube root of it, or we can square that number and then take the cube root. But that's always a positive number. And over here for this piece where I was saying that x is approaching 1 on the left-hand side, x is less than 1. Well, yeah, this is a negative number in here. But again, I didn't put in the fact that this is raised to the 2/3 power. So I'm squaring the negative number and taking the cubed root. And so this is actually a positive number. And so this should have been here 1 plus infinity, which is positive infinity. The other piece was the limit, I guess the left-hand side. As x is approaching 0. I guess it's both of these. Remember, we did direct substitution. The only thing that we had to worry about was when it was equal to 0 in the denominator. And so I only, in this case, have to worry about the second or first fraction. And so when I look at x is less than 0 for this piece, I'm plugging in, we have talked about the 0 here. Well, let's do that. The first piece we said was positive infinity. The second fraction though, plugging in 0, 0 for x, I get 0 minus 1 raised to the 2/3. It's not going to change where I'm going off to, but this is right here, 1 over negative 1 to the 2/3, which is 1 over negative 1 squared, and taking the cubed root. And the cubed root of 1, because squaring negative 1 is 1, is 1. So this is just 1. So I have infinity plus 1 on here, which is infinity. So same idea on this one. I should have, the second one, when x was approaching 0 on the right-hand side, we reasoned this one out because we can't just plug in 0 and got infinity. But technically, for this piece, when I plug in 0 for x, I get the same thing I got up here, which we saw was 1. But again, infinity plus 1 is just infinity. Okay. Just going to erase that so it's not as messy. Okay, so I just wanted to clarify that. Okay, so we're looking at an example with a trigonometric function, and the limit in this case is x is approaching pi halves on the left and the right of tangent of x. So tangent of x, we have to worry about because we have tangent of x has a variable x in the denominator. This is the same thing, right? As saying, let's rewrite it in terms of sine and cosine. So this is the same thing as saying x is approaching pi halves on the left of sine of x over cosine of x. And so recall tangent had asymptotes when you graphed it. And so you had to worry about when was cosine of x equal to 0. Cosine of x couldn't equal 0. The values that set cosine of x equal to 0, those were asymptotes, vertical asymptotes. And so I tend to think of my unit circle when I think about cosine or sine or any trig function in certain values. So in here, I know cosine is my x value on the unit circle. And if I think about when is it x0, it's on the y-axis. And so I think about the angles, radians, that would get me there. And so that would be pi halves, 3 pi halves, 5 pi halves, 7 pi halves, or I could either go the opposite direction so we can make them negative. Remember, negative went counterclockwise. And so I could have negative pi halves, negative 3 pi halves, negative 5 pi halves, etc. So there's an infinite number of things that make this denominator go to 0. So pi halves is one of those. And so if you remember, if you don't remember, you can kind of plot a couple of points or important points that would show you what you get. If we plugged in 0 for x, and we're looking at sine x over cosine x, this would give us sine of 0 over cosine of 0. And that gives us back 0 over 1, which is 0. If I think of pi force, which is another angle or radians that we should know. So if I plug in pi force, sine of pi force is root 2 over 2, all over cosine of pi force, which is root 2 over 2. Well, something divided by itself, other than 0, is 1. Oops. Sorry, I need to put pi force here, and this is equal to 1. If I did negative pi force, there's a couple of things I can do, but I'm going to think of it as going clockwise. I think I called that counterclockwise before, but that's clockwise. And this is in the fourth quadrant. So it's basically the same thing as pi force, but I have to be careful because my x value is negative down here and my cosine, my y value is negative, which is my sine. My cosine is positive. So this is going to get me back -1. So at negative pi force, I have -1. Okay. So kind of a review on trig on how to graph. So I can kind of figure out what my graph is going to look like. And I can, based off of that, decide, is that going to be shooting off to positive infinity or negative infinity at those asymptotes. And tangent is going to repeat itself because it has a period of pi. So I could just repeat itself right over here. And so I can see as I'm coming in on the left-hand side, so I'm following the graph on the left-hand side, this one is shooting off to positive infinity. And then if I look at it coming in on the right-hand side, this is shooting off or down to negative infinity. And so knowing what the graphs are going to look like is really helpful. If you have any number in front of your tangent, that's just stretching it. Unless it is a negative number, then we got to worry about reflections, because that would be a reflection across the x-axis. And that would change then where, the direction your value is going as we approached the vertical asymptote. Okay, so we're a question on this problem and asked if we could go over it, which I wanted to do anyways, so I'm glad they asked. So the limit as x is approaching infinity of the rational function where we had 8 minus e to the x in our numerator all over 2 minus e to the x. And so again, if we're approaching infinity and we're looking at the limit as we're approaching infinity or negative infinity, we're looking at what's the end behaviors of our graph going to look like. Is it approaching one number? If so, there's a horizontal asymptote there. If not, if shooting off to positive infinity or negative infinity, it's helpful to know what's going on when we're going to go graph these. And so first, let's think about the graph of e to the x. And so let's think back to algebra and graphing y equals e to the x. We'll recall e is just a number, 2.718, but it's irrational, so it goes on forever. And so if you start plotting points, you can get it that way, or you may remember that it looks similar to this. And so notice that as we look at the limit, as x is approaching positive infinity of e to the x, this is going to be shooting off to infinity. Well, we gotta be a little bit careful because we have this minus sign in front of this e to the x. And so recall, if I put a negative in front of that e to the x. It's like multiplying, this case, this equation by -1. And that's changing my y value sign. And so if I change the sign of my y value, that's a reflection across the x-axis. That's how I kind of remember it. And so that negative coefficient in front of e to the x, so let's just think about the graph first of e to the -x. Well, a reflection of this, maybe you can actually do it on the same axis, across the x-axis looks like that. And so if we look at the limit as x is approaching infinity of e to the -x, that's shooting downwards to -infinity. So this is equal to -infinity. Okay, so that was just a kind of background of what was going on of the graph of e to the x and e to the negative e to the x, so that when we look at this limit, we can kind of figure out what's going on. And so here we have the limit as x is approaching infinity of this. I guess I don't need to rewrite this. If we go in and we plug in infinity wherever we see an x on here, well, the limit as x approaches infinity of a constant, 8, is just 8 itself. So let's just write that. So we got 8 minus, and then we have e to the infinity. And then we have all over 2 minus e to the infinity. Okay, that minus, we talked about this is actually shooting downwards in front. And so this is going to be 8 minus infinity all over 2 minus infinity. And so now we have a problem because 8 minus infinity, that is just -infinity, and 2 minus infinity is just -infinity. So -infinity over -infinity, we can cancel the negatives, is infinity over infinity, which is an indeterminate form. Okay, so that didn't tell us anything. And so we had to look at the term that is going off to infinity. What is the highest kind of power? What we used to do, the degree, but this is e to the x. And so e to the x is that term. And so, and that's the one in the denominator. We want to multiply by that fancy 1 again. And so we're going to multiply by 1 over e to the x, all divided by 1 over e to the x. And so let's distribute that 1 over e to the x to each term in the numerator and each term in the denominator. And while I do that, I'm going to simplify. So we have this limit here as x is approaching infinity of 8 all over e to the x minus, well, e to the x over e to the x is just 1 all over, so 2 times 1 over e to the x is 2 all over e to the x minus e to the x over e to the x, which is just 1. And so now when we go in and do that direct substitution, wherever we see an x, we'll recall as x is going to infinity, e to the x is also going to infinity. So we get 8 over infinity, which is going to 0. And so in the numerator, we have this 0 minus 1 all over, same reasoning, 2 over e to the x. As x goes to infinity, that piece goes to 0. And we have the minus 1. So this is going to be going to 1 as x goes to positive infinity. Okay, so I'm going to take this problem and we're going to do a lot with it. We're going to graph this rational function y equals 2x all over x squared minus 1. So include the graph of the equations of the asymptotes and dominant terms. The next piece of the direction says determine the domain and range of each function. Use various limits to find the asymptotes and the ranges. Okay, so I kind of put 2 questions into one, but graphing this, we should be able to find the domain and the range with no problem. So looking at this, we need to look at what's happening as we go off to positive and negative infinity to find our end behaviors of our graph. So let's first look at that. And so if we go off to positive infinity of this 2x all over x squared minus 1, we see that we get infinity over infinity. And so this is where we went and we manipulated this so that we wouldn't get this indeterminate form. And we did that by looking at the terms on the denominator and figuring out the degree. In this case is 2. So we're going to multiply by a fancy 1. And that fancy 1 is 1 over x raised to that degree in the denominator of the highest term, which is the 2. So 1 over x squared all over 1 over x squared. And so doing that, distributing, we get the limit as x is approaching infinity. Well, 2x times 1 over x squared, that is going to reduce to 2 over x. All over, distributing 1 over x squared to both terms in the denominator. So I have 1 over x squared times x squared is 1, minus 1 times 1 over x squared is 1 over x squared. And so now we're looking at the fact that a number over infinity goes to 0. And so 2 over x, as x goes to infinity, that piece goes to 0. And minus 1 over x squared, as x goes to infinity, that piece also goes to 0. And so we're left here with 0 over 1, which is 0. And so I know that at least on the right-hand side, my end behavior of my graph is going to be approaching 0. I'm not sure if it's up here or it could be coming from down here. But I know it's approaching 0 and we can figure that out in a minute. Same sort of idea as a limit as x is approaching negative infinity. I'm going to have the same problem. I'm going to get negative infinity over positive infinity, which is -1 times infinity over infinity, which is a indeterminate. I would do the same sort of reasoning. And so when I looked at the limit as x goes to negative infinity, I can look at the equivalent form 2 over x, 1 minus 1 over x squared. These pieces go to 0 again. And so I can see that this also is going to go to 0. So again, I know that my graph has a horizontal asymptote at 0. I just don't know, is it above or below the x-axis as I'm approaching? And we'll figure that out again in a moment. So we just found out by this that we have a horizontal asymptote, and I'm going to call it HA, at the line y equals 0. Okay, so now we want to look at vertical asymptotes, or the domain. Our domain . when we find the domain of a function, we're looking at our trouble spots. I look at my trouble spots. What's going to either give me a 0 in the denominator if I have a variable there, or what's going to give me a negative under an even powered radical, because they can't have a square root or the fourth root or sixth root of a negative number and get back a real number. And so here I see that if I factor this, I get the same thing as y is equal to 2x all over, factoring the denominator. I have a difference of squared, x squared minus 1, x would be x minus 1, x plus 1 in factored form. And so I notice that x cannot be 1 or negative 1. And so that's where I'm going to have problems. If this set my numerator equal to 0 also, it wouldn't be a vertical asymptote. It would be a removable discontinuity. But negative 1 and 1 doesn't set 2x equal to 0. So I know that I have a vertical asymptote at 1 and negative 1. And so I need to see what's going on. Am I going to be shooting off to positive infinity or negative infinity as I'm coming in on the left and the right of both of those values? Okay, so let's look at the limit as we're approaching on the left-hand side of, let's say, negative 1. And so if I plug in negative 1 where I see an x, 2 times negative 1 in my numerator, that gives me negative 2. And if I'm plugging in negative 1 on the left, that means I'm choosing a number that is less than negative 1. But if I plug it in here for x in the denominator, I'm squaring that number. So that's a positive number. And it's a positive number and it was less than negative 1. But if you square something that is a fraction, that's even getting smaller. And so that number minus 1, I can see is going to be negative. And so since it's negative and I have that negative 2 on front, this is going to go off to negative infinity. Actually, sorry, negative and negative. So we're going to have, it's going to go to positive infinity. So this is going to be coming up here as we approach negative 1 on the left. And so if that's the case, then my graph.
The denominator be positive?
But I'm squaring. So let's say let's just choose a number. So if I think of this, it would be negative because, oh wait, actually, sorry, it's less than negative 1. I was thinking left of 1. You're right. So that would be like is more than negative 1. So that would be like negative 1.1. And so squaring that number is going to be more, it's going to be positive, and it's going to be more than negative 1. So this is a positive number. Thank you. Positive number, very small though. And so a negative over a positive is negative. So that actually changes the direction. So this would be shooting downwards.
I have a question.
Yeah.
How come you plugged in -1 for the top, but then you chose something less than negative 1 for the bottom? Why don't you plug I know you can't, but why did you do that? Is there like a rule, or a reason for that?
Because we're getting 0 in the denominator when I do that. It would be okay if I was getting 0 in the numerator, but I can't have 0 in the denominator. And so I know that that number, if I choose it less than -1, it's going to make this close to 0, but not actually 0. And so I can see then, is that going to make the graph go up to positive infinity or down to negative infinity? And so that's where I have to kind of start doing that reasoning. Am I going to get a positive number or a negative number here? And that will help me. Am I going to get this going to positive or negative infinity? If I could just plug it in, I would. But this is making the denominator 0. And so I know we have an asymptote. So I have to kind of do some reasoning on, is it positive or negative? So hopefully that clarified.
Yeah, thank you.
Okay. And so when I plug it in on the right-hand side of -1, so I'm coming in on the right-hand side. Well, again, I'm okay in the numerator just to go in and plug in -1 because that's going to give me a number. I can't have 0 in the denominator. So if I plug in -1, I get -1 quantity squared, which is 1, and 1 minus 1 is 0. So I'm choosing numbers that are get close to -1, but this time on the right-hand side. So like -0.9, -0.99999. And so if I take a number like that and I square it, it actually becomes a number, I believe, less than 1. And so a number less than 1 minus 1, I know is a negative number. Oops. But that negative number is close to 0. And so that's negative. So I have a negative over negative, a negative that is close to 0. So this is going to give me a going to positive infinity. So I know that this is in here shooting upwards. Notice that I can see that we have a y-intercept. Let x equals 0 of our original equation. We got 2 times 0, all over 0 squared minus 1. So we get 0 over -1. So I can see that I'm going to cross or touch the x-axis at 0, 0. So now I need to see what's going on as we look at the coming into 1 on the left. Another way we can kind of think about it, x minus 1, x plus 1. I don't know if that helps you, but when we're plugging in numbers which are less than 1 in this case, because we're coming in on the left, if I do direct substitution, I'm okay with the first number, this piece. 2 times 1, that's 2. If I plug in 1 for this first factor, though, that gives me 0. So we got to worry about that one. But if I plug in 1 into the second factor in the denominator, that's going to give me times 2. So we're just worried, is this, when I plug in a number less than 1 and I subtract 1, is that going to be positive or negative? Well, a number less than 1 minus 1, that is a negative number. And so I know here I have 2 all over a negative number, times 2 is a negative number close to 0. And so that is going to be shooting off to negative infinity. So that kind of tells me then that because this was my only intercept and it's shooting down to negative infinity, it's going to look like this in between those two vertical asymptotes. This is, if I throw my pen, this is where we could use the fact of symmetry to help us graph these things. So we could have found, is this an even or an odd function? Would this be a reflection across the X or the Y axis? But we didn't do that. So let's just look at the last one. So the limit as X is approaching 1 from the right-hand side. Okay, so limit as X is approaching 1. I'll just move the screen up for a minute. On the left or right-hand side of 2x all over x minus 1 all times x plus 1. So if I'm plugging in 1 on the right, well, that's not going to matter for my numerator. I get this 2 times 1, which is 2. If I plug it into the first factor, that's where I have that problem. If I plug it into the second factor, 1 for x, I get the 2. Can't have 0 in the denominator. 1 is coming in on the right, so I know that x is greater than 1. And so if I'm putting in a number greater than 1 and subtracting 1 off, I know that that's a positive. And so I would have 2 all over a positive number close to 0, which is going to mean that this is going to go to positive infinity. So I know that this piece coming in on the right-hand side has to shoot upwards as we get closer and closer to 1 on the right. And we talked about our horizontal asymptotes being at 0, and we already found our intercepts was the 0.00. I can see that's going to be the same for my x-intercept. And so we, by using limits, we're able to graph this rational function. So this was something that you had done before previously in college algebra, graphing rational functions, but we didn't use limits to help us. There was one more part to this question, right? I made it kind of a dual question. It was asking about the domain and the range. Well, the domain we already kind of talked about, we had to exclude those values, 1 and -1. And so I guess I could write this as an interval notation. I have -infinity all the way to -1, not including. So I use a parentheses. Union. I have all the numbers between -1 and 1, but not including. So parentheses, -1, comma 1 in parentheses. Union. And then I have all the numbers from 1 not including to infinity. That was our domain. And now we're going to look at the range. And so range, it's possible to cross a horizontal asymptote, but it's never possible to cross a vertical asymptote. And we found that this actually is crossing our horizontal asymptote. And so our range, if I look at all the y values I'm hitting, there's no y value that I don't hit. I'm hitting everything from -infinity to infinity. Range is the only time that we use the y values when we're looking at interval notation. Other than that, we always use x values using interval notation. And so knowing where your asymptotes are can help you find what your domain in the range is and your intercepts.